second thing is the accelerometer. It measures the vertical acceleration of the vehicle body. So basically, the accelerometer measures the vertical acceleration, and from this acceleration reading, we just double integrate these values to get the terms of dimensions of the meters, so that we can use it further for the profile construction. So it measures the vertical acceleration of the vehicle body, and it is used to find the inertial reference which defines the height of the accelerometer. So the height can be determined by double integrating the accelerometer reading, as I have told you. So going further, the third instrument which we can use is the distance encoder. This is used to measure the distance traveled. So this is the instrument which is used for measuring how much segment which we have traveled or which we have used for our project. So it basically gives the total longitudinal distance which we are taking as a part in our consideration to get the results. And fourth instrument is data acquisition card. So data acquisition card collects all the reading from all the sensors at a time and converts these readings to digital forms, and so that they are available for our algorithms or computer software programs, so that we can feed and get the results. And the last is the processing unit. A laptop or an embedded system board could be used for processing our data and to get the results. And what are the important parameters? There are various parameters which are used for analyzing the road surface. These are profile construction. We construct the profile from the data object. Second is the texture measurement. We get our value for texture. And third is the IRI, International Roughness Index. We can also get the value of IRI. This is the International Roughness Index of the road. And fourth is the bump detection. So in these 4 bars, we have basically concentrated on our first 3 bars, basically the profile construction, texture measurement, and the IRI. The fourth part is actually the further time we can say. So 3 parts we have taken in these 2 months. So what is the profile construction? In detail into these, what is the profile construction and how we construct? What is the algorithm behind these? So a profile construction, the readings from the accelerometer and the laser sensor is required. What are the basic raw readings which are required for the profile construction? Are the laser readings, laser sensor readings, and the accelerometer readings. So as already told about their functions, the laser and the accelerometer, and laser sensor is used to obtain the reading and the height of the road to the reference. We get the height of the road from the reference, or reference is the accelerometer reading. And second, the value comes from the profile construction. We use to calculate parameter like IRI. So with these 2 readings, we are also going to use for the calculation of IRI. So what is the algorithm behind the construction of a road profile? So we double integrate the value. We simply apply a mathematical formula for the accelerometer readings, because accelerometer is in meter per second square. We need to convert this meter per second square to meters, perform a certain mathematical formula to get the profile construction. So we double integrate the vertical acceleration readings obtained from the accelerometer. So basically, in analogy with this, we have applied a formula st is equal to ut plus half it is square. This is mechanics formula we used for uniform acceleration. So basically, we have come to this formula because we are getting the accelerometer reading at a particular time, and we are using this particular time accelerometer reading in this formula to get the distance. And what is the second step? Then we algebraic sum of st and st is taken to get this for each sample to get the full road profile. We apply these formula for every sample, and we get a final st minus st and then we get the full road profile for a particular track which we are considering. So basically, this is the flow diagram or block diagram representing the computational construction of profile. The accelerometer reading we double integrate, and in parallel we take the laser reading, pass to the data acquisition system, and then we apply a summation block and pass to a high pass filter to get a profile. this is the meaningful data which we obtain in the first part of our project which we have done. And this is the mathematical equation for road profile, that for every sample that is right hand t and pt, we get a profile that is for each sample, double integrating the acceleration reading twice, you get the in terms of meters, and we separate these from the laser readings to get the road profile. PT is the reconstructed profile, AT is the reading of the accelerometer, and ST is the height measured by the distance. So the profile which we have obtained is not necessary that it is removed from the noise or it is noise free. It may contain noise. So basically we use certain filters to remove this noise. So the filters which are used here are IR filters. But the disadvantage of this filter is that these are analog filters and we are taking the samples and we are basically dealing with the digital samples. And these filters are analog filters. We can't use them directly to our readings which we have obtained. So the need is to convert these analog part to the digital part. So we are applying certain mathematical techniques like bilinear transform. This is basically a discretization technique. We discretize the analog values to digital samples by taking the transfer function of the filter and converting them, taking the G transform of them and converting them to in the discrete form. As you know that G transform takes the samples, works on the discrete part of the form. So we take the G transform of the transfer function of the analog part, and then we get this equation, filter equation. So here these B0 and A are the constants of the filters. These are fixed, and this N represents the order. Basically, this is the general filter equation. This can be of any order. So changing the value of N, we can get the order. So basically, finally we got that third or fourth order is the most suitable filter used for filtering our results and to get noise-free results. So we have applied on two functions, taking basically two sinusoidal waves to get the results. So taking the frequency to be 3 Hz, one sinusoidal function, and the 40 Hz, another sinusoidal function. And we applied to IR filters and to get the results. This is basically the noise readings which we have obtained, and this is basically the noise-free readings which you can see. And these readings are obtained from the two sinusoids by combining two sinusoids, that is 3 Hz and 40 Hz, and then passing through the filter. These are the laser readings which we have obtained during our run in the field site. These are the laser readings, and these are the accelerometer readings. So by combining these readings, we have obtained the profile which I mentioned before. The later part will be explained by everybody.
So we have discussed the profile construction, that is the first parameter of the road surface. So the next parameter is the texture of the road surface. The road surface is a deviation. Texture is a deviation from the planar surface. Actually, we are dealing with three parameters, that is micro texture, macro texture, and mega texture. So in this project, we consider this the macro texture, that is from 0.5 mm to 50 mm. That represents the sample distance. We just use the 50 mm sample distance in our project. So we will deal with macro texture of the road surface. So for the texture measurement, we will calculate MPD, mean profile depth, that signifies the texture of the road surface. For texture measurement, we will use only the laser reading. No reading of accelerometer is required for measurement of texture. So algorithm for texture measurement. First of all, we will divide the whole profile into segment of 100 mm. Then the second step is that we will calculate the highest speed in 100 mm segment, in each 100 mm segment. The third step is that we took the average of all the peaks in the 100 mm segment. The fourth step is to subtract the average value from the highest peak. so that we will get a particular value in each 100 mm segment. And the last segment and the last step is to calculate the average part of all the 100 mm segment which we have taken the difference, the average value of all the differences, so that we will get final value of MPD. So you can check here. We will just discuss that it is the 100 mm segment. We just took highest speed and take average of all other peaks, and finally we took the difference of highest peak minus the average peak. This is for the first part. Now we will calculate the same thing for the second part and continue doing the process until we will finish the whole profile, so that we will get the average value of mean segment there. First part, for the second part, and for the last, for the all n parts. Our next parameter is IRI. IRI is the International Roughness Index. It deals with that how the road is more rough. So it's the also important parameter for the measurement of road surface. IRI is computed from the longitudinal profile. We will use quarter car model for calculating the IRI. The quarter car model, we just fix the certain parameters for IRI, so that we can consider it as a golden car, and it is necessary for calculating the IRI. We have to set certain parameters to calculate IRI. IRI is measured in meter per kilometer or inch per mile. It is the unit of IRI. So as we discussed earlier, IRI is for the calculation of IRI, laser sensor reading and accelerometer reading is required